For those of you who don't know me, my name is Jim Kemper. I manage the High Altitude Emissions Research Lab for the Department of Health out in Aurora. We've got a full certification level laboratory where we can do the same test that the manufacturers do for emissions testing. It's about a 3-day test. But today, and I also do a lot of tech nights with diagnostic repair type things for the emissions program, but today we're here to talk about revisions to the program that will begin January 1, 2015. So where are we going to go? Well, just talk a little bit about the air quality. We haven't been in front of you guys with anything about air quality in years. We haven't talked about it much, so this is a good opportunity to just review it. I won't spend a lot of time on it. It's just a few slides. Just going to kind of update you because the emissions program is changing, and it's changing substantially because of the air quality, the changes in the air quality. So that's why you need to just kind of understand a little bit about what's going on out there. I then want to go through and give you a review of the current program. Most of you are probably pretty familiar with the program. You kind of understand what the test is, and you understand what the rules are and all those kinds of things. But just to be sure that everybody kind of remembers those, I'm going to go over those, and then that way you'll know what's changing, which is going to be our third item. Then we're going to review the upcoming program changes. And then where I'm going to end this session at is I'm going to start talking about repair information, repair, diagnosis, and repair information. Just start, just a few slides, and how it'll affect you. Then we'll come up probably in the first quarter of next year at some point and start really having a whole session just on repair, diagnosis, things like monitors, how do they work, things like that. So that's where we'll end this session tonight. Any questions about where we're going? All right, let's start then. So air quality. Let's talk just a little bit about the air quality background. So when the original program started back in the early 80s, the Denver metropolitan area was in non-attainment, meaning it violated the National Ambient Air Quality Standards for carbon monoxide. And that's where our emissions program was focusing on, was carbon monoxide, and did for years and years and years. However, give yourself a pat on the back. We haven't had an exceedance for carbon monoxide since 1999. And you guys had a lot to do with that. It's repairing those vehicles. Some of it has to do with the design of the vehicles as they come out. All that together works where we fixed that problem. In fact, we were, in 2006, we became the first area in the country to go into attainment for all 5 criteria pollutants. That was good. Nobody else had ever done that before. Until 2007 when we violated for ozone. The next year, we went into non-attainment for ozone. We knew back in 1998 that it was probably, we predicted it might be a problem, ozone. So we started tailoring the emissions program a little bit, started making a few changes to try to combat this ozone problem. And the current focus of the program and why we're doing some of these changes, or at least part of why we're doing some of these changes, is because we're focusing more on ozone. We're trying to combat the ozone problem in the Denver metro, along really the whole Front Range. And that's what we're trying to work on now. So ozone, what is ozone? Well, a lot of you heard, well, ozone, I heard that stuff's bad, or I've heard it's good. I heard we want more of it. Yeah, right. So that's true. We do want stratospheric ozone. That's the stuff that's way up high, above 38,000 feet. There's ozone up there that protects us from UV rays. That's what you've heard about, the ozone hole, the ozone layer, things like that. It's good stuff. Welcome, guys. Come on in. But there's this other thing called tropospheric ozone. That's what we're concerned about here today. That's low-level ozone. That ozone is not good. Anybody here remember distributor caps? Somebody remember? But you might even have seen one a couple of times. So when you opened up and pulled the distributor cap off and you looked inside the terminals, saw how corroded they were and all of that, that's ozone. That's generally, most of that was caused by ozone. There's very high ozone concentrations inside the distributor cap from the spark that goes from the rotor out to the terminal. That stuff's very bad if it gets in your lungs. It does the same thing inside your lungs. Ozone is a secondary pollutant. So carbon monoxide we call a primary pollutant. That means it comes right out of the tailpipe. But ozone, on the other hand, doesn't come out of the tailpipe. It's not emitted out of the gas tank. What it is secondary, meaning that it's formed in the atmosphere from primary pollutants, which are VOCs, you guys could call it hydrocarbons, it's a little different, but volatile organic compounds, but they're really reactive, and sunlight, heat, and NOx. All that forms together to create ozone. If we can interrupt either one of these, we call them precursors in chemistry. So if we get in one of these precursors and interrupt, pull one of them out, reaction stops. So that's what we're trying to do with part of the emissions program. The effects, we'll go through like this just shows the effects triangle. This means that the proportion of population affected is very great, but the severity of the effect isn't all that high. As we move up in severity, it affects smaller portions of the population. It also tends to just affect certain populations more than others. People that are old, or very young, small, children, people that run outside. You know, if you do a lot of outdoor activity, really strenuous activity, you're probably going to be affected by ozone more than perhaps somebody else that's not doing that. So this just shows it really affects us all. So the ozone standard really we had a standard before 1979, but I want to talk about the one that started in 1979. That was a maximum 1-hour standard, and it was 0.12 parts per million, or we could call it 120 parts per billion. Okay? That was a standard back in 1979. More research came out. There was more research performed. We understood it a little bit better. There was more information on atmospheric chemistry, the chemical pathways that we used that were occurring to form ozone. So in 1997, they changed this National Ambient Air Quality Standard in several ways. First off, they dropped it from 120 down to 80 parts per billion, or 0.080 parts per million. We also understood from the health effects, it wasn't just so much its high amount that was bad, a low amount is also bad if it's over an extended period. So rather than do a 1-hour standard, we go back to, or we increased it to an 8-hour standard. And finally, because ozone it goes up and down, it's really affected by meteorology as much as it is from the actual emissions. How many clouds are out there and things like that. So they introduced this concept of design value. It's complicated, I won't spend a lot of time on it, but it's the 4th highest average concentration over a 3-year period. Okay, so we keep the 4th highest, average it all out, that has to be equal to or less than the 0.80. And actually in this old standard, because of the way they did the rounding, it actually has to go above 0.084 parts per million. Finally, in 2008, more research, understood a little bit better. We kept the design value and all those things the same, but we dropped it again. Okay? What's it look like out there? So I know this is a busy table. Let me just kind of talk you through it here. So along the top up here, we've got the 3-year average. Remember I told you it's a 3-year average for ozone? So these are blocks of 3 years. First one's 2000 to 2002. Next one's 2001, 2003, and so on. Along this vertical axis here are the air monitoring stations that we have kind of scattered around through the Front Range. So at the old 0.080 ppm standard, that was the violations that occurred back in these time frames, in those 3-year time frames. So there was 4 or 5. Everybody see that? Now in 2007, when we violated, they also lowered that standard. That's what it looked like. And they dropped it down to the 0.075. So you can see it changed a lot. Now the other thing, starting sometime, well, not starting. So the EPA has been under this court order for years now to go back and look at the ozone standard even yet once more. And the science, most people kind of accept that the science justifies a 0.060 to 0.70 ozone standard. And they're under court order to change it or leave it alone, but do something with it by the mid-December. I think they'll probably do it, but it's like predicting the stock market. And if they do, because they're under court order, but They have missed it in the past as well. So it's possible they may not, but if they act, they may not do anything, or they may lower it, and if they lower it, then we don't know what to. But if they take it down to the very top of the standard they've been talking about, 0.070, this is what it looks like. Could go to 0.065, maybe they'll leave it alone, nobody knows, like stock market. I can't tell you what the stock market's going to be next year either. But if it drops down to 0.070, it's going to even be harder for us to meet the ozone standard. We may see other additional changes to the emissions program, who knows. But all this would be years out, because once they set that standard, it takes several years just to get it in effect, and then it takes several years for us to develop what we call a SIP, State Implementation Plan. It's kind of a contract between us and EPA, and we say, okay, here's what we're going to do. We're going to do this, 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 and this, and then we're going to, and if we don't do it, then EPA can come in and give us sanctions. So just so you know, so that's the problem, what we're up against right now. The ozone non-attainment area looks like this. Now for carbon monoxide, we tended to have it centered right in the metro area. It was centered kind of up in Fort Collins. It was centered around Greeley, so the old program was a little smaller, because carbon monoxide tends to be really focused in just certain, highly densely populated areas, even down here in Colorado Springs. However, with ozone, it's more of an area problem because it's a secondary pollutant. So we all of us here are living in this kind of atmospheric bathtub. We've got the Palmer Divide on the south, we've got Cheyenne Ridge north of us, and then we've got the mountains on the west. So that water or air just kind of sloshes around like it does in a bathtub. And all the emission sources, they start mixing and they start cooking. So that's why with ozone, rather than really focus as much on the population areas, we got to focus on all these a much larger area. That's why we got to bring in Weld County. That's why we got to bring in Larimer County, portions of Larimer County. So it's a much larger problem, or it covers a much larger area than carbon monoxide did. Real quick, these are just the sources. All you can see, or as you can see, the carbon monoxide, almost all of it's mobile sourced. Carbon monoxide, 90% of it or more comes from just transportation sources. Cars, trucks, things like that. The VOC, you guys call hydrocarbon, okay, it's a little different, but it's close. The VOC inventory, mobile is still a pretty good chunk of it, mobile sources. And that's what we're focusing on with the program, trying to get those down. And NOx, mobile's a pretty good chunk right there. Okay? So that's why we have the emissions program, that's why we're going to continue to have the emissions program, why we're going to continue to focus on making it as efficient, if you will, as possible. All right, any questions about that? Real quick brief. What's that?
ONG.
Oil and gas. Yeah, oil and gas. So that's all the wells, Weld County, we've got all those wells out there. It's a huge. Now methane isn't particularly reactive. The lighter ends, methane and ethane, which is a lot of what those things used to give off. But there's so much of it that it overwhelms the source. So, yeah, that's oil and gas.